Hello. For the tests on population mean, you want to use the hypothesis testing for mean that's on Canvas in Chapter 9. And then you want to enter these values here, and it will give you everything that you need. So if we look at number 5, it says it takes an average of 12.9 minutes for blood to begin clotting after an injury. An EMT wants to see if the average will change if the patient is immediately told the truth about the injury. The EMT randomly selects 49 injured patients to immediately tell the truth about an injury, and notice that if average 12.7 minutes for their blood to begin clotting after their injury. And they give their standard deviation. We want to test 0.01. And he was testing that it differs from the 12.9. So it's a t-test because the sample size is, I think it was small. Oh, sample size is pretty big, but the standard deviation comes from the sample, so you still use a t-test. And our sample size, 49. Population mean comes from the hypothesis, 12.9. The sample mean was 12.7. Standard deviation, 5.09. And we want significance level 0.01. So then the test statistic, right here. And the p-value, since it's not equal to, it's a two-tail, so it's this one here. And then you look at the p-value in alpha. The p-value was 0.7, which is greater than alpha. So we fail to reject. We'll do number 6 also. A consumer group claims that the average annual consumption of high fructose corn syrup by a person in the U.S. is 48.8 pounds. You believe it's higher. So this time we're testing greater than. And that's why it was greater here. And this was the population average. And we get a sample of 34 people. So sample size is 34. Population mean from the hypothesis, 48.8. Sample mean was, find an average of 52 pounds and a standard deviation of 4.1. Test at 10%. 10% as a decimal is 0.1. T-value 4.551. This one was greater than that we were testing. And so greater than points to the right. Now the reason it's 0, it's 3.44, but that E means times 10 to the negative 5. So this decimal is going to go to the left 5 units. So it's going to round to 0. 0 is less than our alpha. So we reject.